Welcome to the Vox Pathfinder 15R channel, and today I'm going to show you how to bias one of these beasts using two methods, the stock Carvin method and using the SRS company method using their data sheet. So let's grab this, how to bias your Belair 212 or Nomad, So I've read through this, so I'm not going to go into every little detail. But here they tell you to get your equipment, take the chassis out of the combo. That's done. Plug the speaker input in. Yeah, you want a speaker load. Make sure it's matched. Let's see. So they say lower the volume on both channels. That can be important. Okay. Unplug the guitar cord from the input. So you don't want any signal going through this amp whatsoever. That'll corrupt the measurements. That's the whole point of that. Go to the next page. Okay, so we're going to connect up to the standby switch. Did we skip some parts here? Okay, so we're going to hook up to the standby switch. So I'm just going to go through that routine. So I'm going to unplug everything. I've bled the caps off. Okay, that's disconnected. I gotta slacken my reverb. So what I'm going to do is I'm going to put on two blocks of wood onto the chassis. And then I'm going to flip it back down. Unfortunately, these blocks hold it up enough for these tubes to interfere, but with the SRS tool, it's not enough. Okay, so I'm going to put this here. Okay, so now try to be careful any residual voltage, even if you did your homework to discharge. Always assume it's charged. This is the area to be careful of in here. That's where like the high voltage is. So let's see if I can do this. Okay, I want to flip this. I can flip that. One second. Might want to detach the other reverb. That would probably work best. Of course, tubes are resting on the block. That's not a good thing. Get these wires out of there. And fortunately, it does clear. And actually, for the presentation effect, let me just rotate this as much that way as I can. And it's somewhat stable. So we just have a little bit of clearance. I thought I was going to have to shoot it over the edge. Okay. So we basically want the standby, is it still filming? We want the standby to be out of the circuit. Like, we're going to use this meter and we're going to use it in amps, DC. So here I have a selection for 10 or 250. I have no choice, but I have to put the 250 on. And we're going to want to go across the standby switch. I've done this in the past. I can take an ohm meter reading, just to make sure I know what things to bridge across. So this is the standby. So I think I have to go between here and here. The meter shouldn't run. If I put the standby on, maybe it should make a connection. So I'm going to figure out which two ports. Oh, I'm sorry. I have it way on the other side. So again, it's on standby. So take it out of standby. That's going to be tricky. There we go. So it's across those two. So you're going to put it on standby. What I like to do is I like to get a little bit of these alligator clips and clip it onto the terminals. Like so. Terminals I just proved to myself are the correct ones to use. And then put these probes to those terminals, but in such a way that nothing touches. So you're just going to have to finagle that for a while. I'm thinking I'm going to go that direction is dangerous because that's the power. There you go. I'm just going to go up. That didn't work. Just keep doing it until you have a safe setup. Let's just test that out. We're going to leave it on standby, so we're not going to fool around with that. Let me just show you closer what that looks like. Okay, so you want to get the two probes there, and what you're going to do is once that's in effect, you're going to put this onto the milliamp setting, or current setting to 250. Here for me it's going to be 250 milliamps. And we're going to leave the standby switch off, and this is effectively our standby switch. So we're not going to have a standby, we're just going to flip the amp on. It's just going to heat up from a dead cold, which is alright. Okay, how does that look? Okay. Directions. So we did that. So now we're going to want to plug the power cord back in. Again, careful of your fingers. Don't put them into the chassis, especially if you don't know what is in the what lurks. And just got to keep checking that this board's not going to fall off. Okay. So what we're going to do, we're going to turn it on next. And then we're going to look for the the bias after we turn it on. We're also going to alternately use this SRS bias tool, if I can get it to stay up here. Okay. Or not. Hold on 1 second. Okay. All right, so I'm going to put the voltmeter on down here, and this is hooked up to the SRS bias tool, and you saw this from a previous video. So just go, I'll put a link on how to set up the SRS bias tool, and you can see how to do that. Alright. Okay, so we got the 2 voltmeters, or 2 meters I should say, hooked up. I have a little device here for adjusting the bias. And we'll see. So they say turn the power on, wait 2 minutes, and you should see the meter read the current. It will start to slowly increase up to 75 milliamps. Adjust accordingly. Check your meter at this point. If it goes above 75, lower it by turning the bias potentiometer, which is on the board over here. You're going to use a tool like this, like a chopstick ground to a flathead screwdriver like. So if it goes over 75 milliamps, lower it by turning the bias potentiometer with the screwdriver clockwise. If it's under 75 milliamps, bring it up by turning the potentiometer the other way. Okay. And that's about that. So let's see what happens. Cross your fingers. Okay, so the arm's starting to climb back up on my ammeter. I'm starting to read current now on the SRS tool. It's at 50 milliamps and climbing. I'm gonna check the bias. So I have from the previous video on tube A, I have 7 milliamps of current going through the cathode, and on tube B I have 16. And I have approximately, well, 62 milliamps going through the standby switch. Now they say something in here that's kind of hokey. Let's see if I can get it, if I can find it again. This is the Carvin manual. It's okay, we're just going to let this burn in for a bit. Now I got 8 milliamps on tube A, which I was getting before. They want you to adjust to 75 milliamps across the standby switch. And I think it's even printed somewhere on this board. Now, in here, they say, and I can't find it now unfortunately, but I've read this before, they say if you adjust it to 75 milliamps across the standby switch, that'll result into the, oh here it is this it? When you've changed the tubes, make sure they are match set. This isn't. When you bias the amp at 75 milliamps across standby and the tubes are matched, you will have the desirable 20 milliamps going through each tube of the 4 power tubes. Now 4 times 20 is 80. How do you get 80 if you're only letting 75 milliamps go through the standby? That I don't understand. Okay, so looks like we could bias this just a tad bit hotter. It's like I got it a little bit cool. Not a match set. That's fine. Now, that's this method. We would adjust this to 75 using the reading across the standby switch. Now, using the SRS method, they have a formula to use. Now this formula says, for instance, let's say you have your stock EL84 tubes. They would say take the dissipation, max dissipation of an EL84 tube, which is 12 watts, multiplied by this number, 500, and then divide by the plate to cathode voltage. In this case they say 300. And then you would plug in 20, you would bias it until you saw 20 milliamps running across their tool per tube. And they said if you wanted to account for, screen dissipation, for a 12AX7, that's an additional 2 watts. So you would just go, you'd plug in 14, 2 plus 12 is 14, and then you would use their other multiplication factor, 700 this time if you're going to use the screen voltage, divide by the plate to cathode voltage on your amp. And then you could run as much as 32 milliamps through tube while looking at the SRS tool. So what we're going to do is that we're going to bias this to 75 milliamps like Carvin wants. Then I'm going to shut it down, and then we're going to get a plate to cathode reading, and we're going to look at this other device. Okay, so you go in here, and there's a little slot, and you turn it, and you keep your hand away from the chassis. There we go. Now I'm biasing it too hot. So I'm going to cool that down. And I'm right on 75 milliamps. So let's get the camera closer. So there we go, dead nut 75 milliamps across. And you want to, this device, there's going to be a slot, and you're going to want to fit this slot and turn it. That's the potentiometer, bias potentiometer. According to Carvin, that is now biased. Now we'll look at the current. And this tube, I have 9 milliamps on current A, current B, 18 milliamps. Okay, so they're not a match set because I replaced a broken tube. Now I'm going to power down, and we are still at 75. I'm just going to take out the power cord for a second. Or maybe not. Take out the probes. Okay. So gently take out the alligator clips, because we're no longer going to use that. Now what we're going to do is we're going to take a plate to cathode reading. And what we're going to do is, if you look at these underside of the power tube board, you're going to see these pins, right? And we're going to look between pins 3 and 7. So you know this is pin 1 because they marked it pin 1. So 1, 2, 3. Okay. 1, 2, 3. And you go 4, 5. 5 is noon. 6, 7. So I know 7, and there's 9 altogether, so there's 8, 9. So I'm going to go take a reading between 7 and 9. All right, now, can I take a voltage reading that high? I would love to do 250, I'll bring it to the top of the scale, but I know the voltage is going to be higher than that. My other voltmeter only goes up to 200. So we're going to pick the 1000 scale, and we're going to do our best to see what that is. So 1000 scale, so we're 50, 100, 150, 200, 2. So that's basically going to be 200, 400. So we're not going to get much, 200. So there's going to be 300s right in the middle. Then it's going to go like 320, 340, 360, 380. So I'm not going to get much in the way, but it'll be close enough, right? Just as a sanity check, using the SRS method. So you get like a nicer digital meter, and you get a better reading that way. I'm actually should probably wear gloves for this part. That's pin 7. Pin 7 has the voltage, right? I didn't discharge the caps. Okay, so what I can do is I can put this probe in. I wonder if I can finagle with my little mitt. Let's see. Let's see what the voltage is. Let me just get a reading. Hold on a second, maybe this is not connecting. So there doesn't appear to be a voltage presently, and I have it on DC volts, so it would measure something, and I won't touch anything while I put it on, so I won't be connecting a current. Get between these wires to hold this in place. All right, that looks good. So I'll just do a little close-up. So I've got these alligator clips on pins 3 and pin 7, and we just want a voltage reading to use in the calculation. Okay, so everything's off. Nothing's about to fall off, right? Okay. All right, so we're going to put it on and leave in standby. Make sure the tubes are actually working. Yeah, they're heating up. And let's see if we get a voltage reading. Yeah. We got a voltage reading and it's looking like 400 volts right now. It's going to drop a little bit as more current is being pulled through. And then we'll just do an estimate. So it's looking more like 380 according to this guy. Of course, there's parallax involved with this. Sorry about that. So I'm going to say, according to this thing, we'll call it like I'm going to call it 385. Let's estimate it at 385, right? Or Let's see, I have a magnifying glass. Maybe I could use that. Yeah, it's definitely not on 380. It's not halfway between the two, so it's definitely 385. Okay, so we have 385 on the plates. Now, another bit of research I found is I found this old, let's see, doesn't want to pick this up. Is this too bright? Yeah, it's too bright. This is the old spec sheet for the 6P 14P, right? Now, there's a very important piece of data on this because these Russian tubes, everyone says, oh, they're like the 7189s or something, and they have like that 14 watt plate dissipation, blah, blah, blah. But this is the original spec sheet. And while it's true, it has 14 watt plate dissipation. But look here, UA, that's the plate voltage, 400 for case 1, UA case 2, 300 volt max. What does that mean? And they say at condition 1, where you have it set the plate to cathode at 400 volts, your plate dissipation has to be less than or equal to 8 watts. And it's only when you get down to the 300 volt plate, 300 volt plates, cathode to plate. Hi, Diego. I'm just doing some work. Do you get the benefit of having over the 8 watt dissipation, or more importantly, the 14 watts? So really, if you're up here, you can only do up to 8 watt dissipation. Yeah, I'm doing my job. So, going back to the sheet, I'm sorry, Diego. Let's see if I can get a better thing. Okay, I just had to restart the video. So, as you can see, if we're up at the 400 volt limit, that 14 watt plate dissipation isn't really true. So here's the formula for AB. And they said if you would like to know the absolute high current limit, add 2 watts for the screen dissipation. According to the spec sheet, it's actually, to the original Russian one, it's 2.2 watts. And they say, and then again, change the 5 to 700. So, in actuality, if I'm going to be safe at this high of a plate voltage, I want 8 watts dissipation plus maximum 2.2 for the screen. That equals 10.2. That's max dissipation for plate and screen at this high voltage. Then I'm going to multiply this number by 700. Okay, equals that. And then I'm going to divide by my actual plate voltage, which I estimate at about 385. And I want 18.5 milliamps going through each tube. Which is interesting because if I biased according to Carvin on tube B, according to the SRS tool, which is over here, I'm at 18 milliamps. And tube A, I'm at 10, which is the older one. So that's it. We're going to leave it at there. This isn't a match set, but this isn't being biased any hotter than the 18.5, according to the restricted plate, the plate voltage. So we're going to keep it at that. I'm pretty happy. We got a steady plate voltage, 385. It's 75 milliamps across the standby switch according to the Carvin method, which yielded dead on the money for that replacement tube I just put in there. For the other ones, they could have been warmed up a little, but since it's an unmatched set, I don't want to risk it. Okay. Well, that's been the Vox Pathfinder channel, and I hope you found that somewhat informative. Thanks for tuning in. One more thing. If you take your amp out of put it into standby, this is what happens to the voltage on the plates. Now, does that mean that the capacitors are drained? I just assume in my head, I have, without looking at the schematic real quick, that that's what that means. So are you safe? Have you safely discharged your capacitors just by leaving your amp into standby? Thanks for tuning in. Just for shits and giggles, I decided to plug the other two 84 tubes into the SRS bias tool. So we'll have tube number 1 all the way on the left, and that's running at 12 milliamps. $10 and $18 for the others. Switch to tube B, 22. So what I'm going to do to get this better match is I'm going to put the 10 over on this side and the 12 over on that side, so both sides of the amplifier are better matched to each other. Okay, thanks for tuning in.